So we're going to start off by doing a warm-up by finding the derivative of a few functions, and then we'll start the actual new material on antiderivatives. So the derivative of x to the 5 is, thank you, Dogen, it is y prime equals 5x to the 4. Remember that for the derivative, you bring the exponent down, so you bring the 5 here in front, and then you take the exponent and you subtract 1. So I'll do the extra step here and do 5 and then 5 minus 1. So that becomes 5x to the 4. And for the next one, what do you do here? Well, you do the same thing. Let me just leave the 4 alone, bring that 7 down, and reduce the exponent by 1. So then this becomes, what's the final answer here? What's the final answer for that? Thank you, Jai. 28x to the 6. Okay, whoops. All right, so now I want you to tell me, just let me know in the chat, those first two examples, how were you with those first two examples? Let me know in that chat. How did you feel about those examples? Easy peasy. Thank you, Gianluca. Yeah, hopefully easy peasy. So let's do this one here. Now this last one here is considered like one of the harder derivatives. I don't mean in all of mathematics. I just mean what I taught you in the fall. Looking good, Jai. That's the right answer. So I'm going to do this one according to this red thing here, the power of a function rule. So you bring the 4 down, and then you take this function, this cubic, and you take away 1. But then you have to multiply by the derivative of this stuff. So the derivative of 2x cubed is 6x squared. So that's 6x squared. And then you can tie it all together, or I can just copy and paste Jai's answer from the chat. Literally, I would do that, but I'm quick on the keyboard today, hopefully. And you get that. Okay, so these 3 examples I would consider prerequisite for this course. If you had a tough time understanding these 3 examples, then you need to review some derivatives, okay? So you need to review the power rule, and you need to review the power of a function rule. So the power rule, remember, is y equals x to the n, and the derivative is nx to the n minus 1. So now the question arises, how do you go the other way? So that is what we're going to be covering today. That's what this booklet's about. It's about integral calculus. Now, when you see the word integral calculus, you're like, what the heck is an integral? And the answer is, I'm not going to tell you today. I'm going to tell you next week. So as far as you care, today I am not mentioning the word integral, perhaps until the very end, until I say, hey, next week we're going to do integrals. But today's lesson is this one. Look at that fancy word there. Antiderivatives. What the heck is that? What do you think that means? Let me know in the chat. What do you think antiderivative is? What do you think that is? That's correct, Jai. Yeah, it's going backwards. So what it is it's this. If I go here, if I go here to this question, let's say I gave you this. Let's say I gave you the thing here, 28x to the 6. And I said to you, find the antiderivative, then the answer would be 4x to the 7. So what we're trying to do here is literally go backwards. And you might be like, why would you go backwards? Hey, buddy, you were teaching us how to go forwards for a month or so in December, and now you want to go backwards? What the heck? Well, there's a huge reward for being able to do that. In fact, derivatives and antiderivatives, I don't know which one's worth more. I think they're equally valuable, in my vast experience with math and physics, I've had to use them both a lot. And they are basically two sides of the same coin. In mathematics, derivatives and antiderivatives are companions. It's not one or the other. You need them both. So what we're going to do now is try to find some antiderivatives. So here's your lesson. Here we go. Example 1. So I want you to think about what we did last semester. I want you to think about the power rule. So the thing over here in red, let me just magnify that a lot. And I'll magnify the other one a lot as well. Don't mind the OCD kicking in. I want to make it the same size. Don't laugh at me too much. Anyway, okay. Can someone tell me now? I appreciate the commentary from everybody in the chat, but I want to see some different names. I want to see some different names in the chat. Can someone tell me in the chat? Someone new? What is the antiderivative of that? Not derivative, antiderivative. Anybody in the chat want to tell me what the antiderivative is? That's correct, Ethan. Yeah, the answer is x squared. So if this stylus thing is too slow, I might switch back to the keyboard, to the editor, the equation editor. Now, how do you know the answer is x squared? Well, most of you will say, I kind of knew because if I worked it backwards, the derivative would go to the front and I'd get 2x. So that's what I'm trying to say here. You can pretty much guess this one, right? Anybody really have too much stress there? You could just guess it. Important thing about notation. An important thing about notation. When you have f of x, the derivative is f prime. You see, you put the prime symbol here. With antiderivative, you do something different. You go from lowercase f to uppercase f, okay? So if you want to do antiderivative, remember that the answer, if it's a function notation, we switch to uppercase of that function. See, f of x like that. Now, is that the only answer? Can someone think of another possible answer? Anybody else in the chat? What would be another possible answer? Is there another way? Ravindra, on point. Yeah, so Joshua, you could put a 1 there, definitely. And I like what Ravindra said. What I'm going to do is I'm going to go a little bit easier than what Ravindra said first, and then I'll put the answer there, because that answer is excellent. So think about this, everybody. Does it matter if I put a number like 1 here? Would the derivative of this still be 2x? What do you think? Would it still be the same if I put a 1 there? Could I put a 1 there? Of course you can, because the derivative of 1 is 0, so it would go away. So in fact, you could put any number you feel like here. So you could put a 1, a 4, a 41, a 41.3. You could put a negative. I don't give a crap. As long as it's a constant, you can put whatever number you like. And for that reason, we always put plus, and you could put, usually the letter C is used, but you could really use any letter you like within reason. And we call that the constant of integration. So whenever you find an antiderivative, remember, you always put a constant at the end, okay? Now, this sounds childish and superficial, but potentially, you could get every single answer wrong on an antiderivative test because you forget the letter C. Obviously, because I am grading your tests, I would not destroy anybody here for not putting the C, but you would lose I would deduct marks for a portion of your mark for not putting that C down. Okay, now I'm assuming some of you have started reading ahead because maybe I'm talking way too much about one example, and I promise I will speed it up. What would be the antiderivative for the next one? Brian. You know, when I see Brian, I see the word brain. Maybe it's because I transpose letters too much. So, Brian the Brain, yes. I should give nicknames to everybody. Ravindra rocked the question. Brian's the brain, the Breakfast Club. I'll find a better nickname for everybody, but like, bear with me. It's 8 o'clock in the morning, right? How creative can you be? So, and I'm pretty good with my alliterations. One day I'll get really cool. Anyway, so the next one here is 4x cubed. So these ones here are so similar to the formula here in red. See on the side here? It's like, it reminds me of like, fast break, LeBron's by himself for a dunk. Like, he's not going to miss it. So that's what you got here, okay? See, if you brought the 4 back up, imagine going backwards in time. If you brought the 4 back up, you would have x to the 4. And if you're not sure if that's the answer, you could always check it. See, how would you check an antiderivative? You would find the derivative. See here? Let me check it. I'm going to check it right now. Check. Okay? If you find the derivative of the antiderivative, let's try that here. So the derivative of f of x, capital F, is going to be, you bring the 4 down, x cubed, and the derivative of c is 0. So yeah, that's good. Yes. 3 check marks, because we're cool. All right, I might switch to my keyboard in a second, because this is not looking too promising. Here's one more, and then we can play with some more of these easier ones. So what's the antiderivative of 5x to the 4? What do we have in the chat? Anybody? 5x to the 4. What is the antiderivative? Very close, Joshua. Just don't put the 4 down. You bring that 5 up, but you are correct. It's 1 higher degree, and then you put a c at the end. And if you're not sure why, remember that when you bring the 5 down, when you take the derivative, that's where this 5 comes from. I really appreciate everybody's participation here. Looking good, everybody. Okay, so there's another, I don't know. We're probably going to go up to example, we'll go up to example 15, and then we'll take a break. Now, don't get too scared, because they are going to go by quicker, I promise you. So the antiderivative of x to the 1. This one's a little bit more challenging, but yeah, the answer is x plus c. Don't forget the c. That's very good work. That'd be a very small deduction though, okay? But that would be that. So all of these questions from 1 to 5, they all have the same thing. They have something very easy where you can just look at it and work backwards. But now it's not going to be as obvious. And maybe we require some type of a formula to help us along the way. So this is the big move, everybody. This is where I can present to you a formula. So if anybody has seen this before, please hold back for a minute, because I really want to give a chance to the rookies. So f of x is x. Wait a second. Now some people here are probably wondering, hey buddy, why don't you just put a 4 here? Honestly, if a 4 was there, wouldn't the answer be easy? Honestly, if the 4 was there, you know it's x to the 4. Like, really? Right? Because we just did that on the previous page. But now there's no 4 there. So I'm going to show you the formula that gets you through this. So I'm just going to copy and paste that formula, and we'll talk about it in some detail. So this is the only formula that we have today. This is your only formula today. I'm going to just drop that formula on the sheet. So hopefully you can see it well. So I think I went too far ahead, but I think I was deliberate. I wanted to go to example 10 next. Sorry, let me take a step back here. I actually skipped too far ahead. Let's do examples 6, 7, and 8 now, and then we'll talk about the new formula. So continuing on the constant ones, if you have a number like 3, can someone tell me what the antiderivative is for that number 3? Yeah, that's right, Jai. You just put 3x. Remember, the derivative of 3x is 3. So we're going to do that several times now because the next two examples, I should say, are the same thing. Because these are just numbers. These are constant. So the antiderivative of pi, just like a number 3, it's pi times x. Now, why am I wasting so much time with constant values? I thought I'd just be, something quick to do. I think that the best way to learn these things is through a lot of repetition anyway. What's the antiderivative of root 3? What's the antiderivative of root 3? If you're not sure how to type root 3 in the chat, you can type in this. That'd be good enough for me. So what's the antiderivative of this? Thank you. Now, when I write it down here, it's not a big deal. I'll put the x a little bit further, or put a dot if you want. You don't have to put the dot there. Okay, so now we're actually getting into the new rule. So I'm actually going to do question number 10 before I do question number 9. So here's an example where you have x squared, and you want to find the antiderivative. Now, I was saying earlier, like the next one after, number 11, you could put a 3 in the front. It'd be so much nicer, because then you could bring the 3 up. But we don't have a 3 in the front, so what do? Well, this formula is on the cover of the booklet, and is the only formula that you're going to learn today. That's new. And it basically says that if you have x to the n, the answer is going to be one of two things, either this or this. So this curly bracket here means it's a piecewise function. That is a function that is defined in two parts, depending on what the exponent is. So if the exponent is -1, then you do this. And if the exponent is not -1, which is the majority of the time, the vast majority of the time, then you do this. So here's a very rhetorical question. Is that number there -1? Yes or no? It's obviously not. So which part of this equation should we use? The first part or the second part? Let me know. First part or second part? Thank you. So that's the formula we're going to use right there. So let's do it right here. Okay, ready? We have f of x. And then the answer is x to the 2 plus 1 over 2 plus 1. And you always put that constant at the end, plus c. And then do some cleaning, and you're done. So that's x3 over 3 plus c. And that, my friends, is how you find the antiderivative of a power function. So, who has never seen this before? Let me know in the chat. Was this easy? Was it weird? Did you understand it? Give me some feedback. Thank you. Let me know in the chat. Thank you, Amir. Anybody else? Thank you, Gianluca. I want to see a few more people. Weird but easy. New to me. Okay, so even though it was new or weird, can you still follow it? Brian, I promise you we're going to do a bunch of negative ones and fraction ones as well. I promise we're going to do a whole bunch of them, okay? All the things that are going through your head about what kind of weird numbers, I promise you we're going to do all this stuff today, okay? We're going to deal with all the BS so that we can focus on the notation next week. And this will be, like what I showed you today, it's going to be very similar to next week. So yeah, let's talk about different exponents, and then I promise you we'll definitely take a break. I know I repeated myself a couple of times about the content, but that's just because I'm thinking about editing the lesson later. For those of you that are not sorry, for those of you that were not in the fall with me, this past December, I do record all the lessons, and then what I do is after class I take the recording and I edit it, and then I put together a nice video and on YouTube, on my YouTube channel. And then you go to the YouTube channel if you want to see closed captioning and you want to see like kind of a nice polished version of the lesson. However, you can also find the raw version of the lesson immediately after class on Blackboard. The reason I publish the videos on Friday. So the reason is because I teach you guys today, but I also teach another section on Thursday. And then what I do is I take the greatest hits from both of the lessons and I cobble together a nice little video. Anyway, let's go back here. What exponent is understood for the x here? What exponent is understood here? Whoops, I'm having issues with my stylus today. Okay, so yeah, let's follow the rule. So we're going to have x to the 1 plus 1 over 1 plus 1 plus c. Now, as I write that, remember I'm using this rule right here because the exponent is not negative 1. So then this becomes x squared over 2 plus c. Okay, so let's take this this formula here. I know what Brian was saying there. If it's negative 1, nothing wrong with that, Ethan. You can also do that, but the reason I don't do that in general is because what if it was this one? You see this one with the 1/3? I don't want you to write 0.33 or whatever you can cut it to. So is that cool? You can leave it as 0.5 here if you want, but if it's really denominators that are not nice, it's better to avoid it. So we will do the negative 1 eventually. I don't think it pops up for a few more examples. I'm just looking ahead. I don't think I have it. Oh, that sucks. I guess I should do that in the next version of the course when I update my booklets. I'm going to answer Brian's question right now. Actually, Brian, I'll answer your question right after 13, and then we'll take a break, okay? So the question that Brian had was this. I'm going to cut question 13 in half, and I'll just do it here, okay? So this is 13b. Actually, I'll just say Brian. Oops. We'll call it the Brian question. I give up on my stylus today. So Brian's question was, what if it was f of x equals x to the negative 1? I can answer that one shortly. Let's just do these three first, and then we'll answer that, and then we'll take a break. So in this case, x to the 3. Now, I don't feel like doing this all the time, and I can imagine that some of you are already weaning off of that. So I'm just going to write the answer as economically as possible. So this will be x to the 4. So you raise the exponent and you divide by the same number. So let's practice that a few times. See, raise the exponent by 1 and then divide by the same number. And you're going to see that these ones are really, really quick. I'm surprised the stylus is working better. I'm going to find ways to optimize this better because then it will really make the lessons a lot more colorful. What's the answer to 13? Let me know in the chat. What's the answer to 13? That's right. Thank you, Ethan. Thank you, Brian. You gotta put your C there. Don't forget your C. So that's x to the 9 over 9. Oops. Okay, so the fun times. How do you do this one? Well, the answer to your question earlier is that you literally just write this down. Okay? So if it's x to the negative 1, you literally just write down the second branch. So the answer is going to be f of x uppercase for antiderivative, and it's going to be ln of x. You have to put an absolute value, and then plus c. So there you go. That's the answer to your question, okay? So if it's -1, you just do that. It's 8:51. Let's take a break. I'll give you guys till 9:05, okay? So in the chat here, I'll just type that. 9:05. No quiz today. This website allows you to find the antiderivative. You can also use other websites, which I'll show you next week, where you can actually do the integral, but we'll get to there eventually. So if I find here the antiderivative of x squared, we did this one earlier, it'll be x to the 3 over 3. See it? X to the 3 over 3 plus a constant. Now, if you're wondering about this notation, we're going to do that notation next week. So today we're not going to focus on the actual the notation for an integral. We're just talking about finding antiderivatives. So I'm just putting it out there for you. And that's pretty much what I want to show you. I also mentioned to students that for anybody that's new today to the section, I do have a YouTube channel, and I'll just show you the YouTube channel quickly. And you can see here that I have a playlist. It's empty right now. See, it says Math1181 right there. It's empty, but I will put our videos there. And for those that are wondering, I have kept the material from the fall. It is available still, as you can see right there. So yeah, that's pretty much what I wanted to talk to you about. It's roughly time to start. So let's get back to business here and continue with the examples. I was scrolling ahead, and I'm pretty sure that I tried to design today's class to be done in 2 hours. Oh, I don't make any money off YouTube, Asim. I'd have to make so many videos that it'd be like whatever. I don't the YouTube thing is just honestly for me to help people. I really don't care about that stuff. I have a good job. I'm happy, and my hobby is just to share math with people. Okay. Yeah, I might do some more stuff on YouTube on sports cards because I love sports cards, as you know. Oh, my channel is called Random Math Guy. And just look for the yellow triangle. Okay. So let's continue here with these examples. So I might become a bit of a keyboard typer. Now here we go. So what's the antiderivative of x to the pi? Now, oh goodness, yeah, that's right, Jai. So don't worry about the pi. It's just a number, right? So you just put pi plus 1. Pi plus 1, see? And don't forget the constant. Now this one here, you need to do a little bit of preparation. So the first thing you want to do here is rewrite this. So this is not the answer. You see it's still lowercase f, but you want to rewrite it as x to the -2. And we did this in the fall. In the fall, if you remember, we did this many times. We had to take the question and we had to clean it up a little bit so that it was easier to use with the formula. So now it's easy to find the antiderivative because you put x to the something over something. Now, granted, it is a little bit weird, but we will get through it. You take -2 and you add 1, and you do -2 and you add 1. And of course, clean this up a little bit because it's looking kind of weird. So this becomes -1 over -1. And as you remember in the fall, I absolutely was just crushing you with exponent laws and such. So I think the best looking answer is that. -1 over x plus c. So yeah,
Sir, why
yes,
are we not using the second one? Sorry, I would use my keyboard, but my
yeah,
computer's connected to my TV.
that's okay. What's up?
Why would we not use the second equation where n equals -1 if it's
Because
x?
because n is equal to -2.
Okay,
What's the exponent here? It's -2.
it's negative
Not neg
2.
yeah. Yeah, it's -2. So it's
So the
got that rule.
so the only time we would use it is if it's -1.
That's it. So it's one and done. So this
So
thing
only
here,
for -1. Anything else we would be using the first equation for.
yeah. So basically, the majority of the time, 99.99999 forever percent of the time, it's going to be the first formula. Yeah.
Okay, thank you.
And we're going to rename that formula for this lesson, for this section. We're going to call it the Brian formula. Okay, we're going to use Brian's answer. Where are you, Brian? Are you still there? Still hiding out? Okay. All right. If Brian, if you feel too stressed out to bear this responsibility, we can shift the responsibility to Anthony, because Anthony just asked that question. So we will shift the responsibility to Anthony. Anthony, are you worthy of accepting this responsibility? You don't have to talk to your television. You can tell me.
I'm not too sure. I'll let you know next week after I get my mark for the test.
Okay, buddy. Okay. Hilarious. All right. Okay, let's keep on going with. Whoa, wait a second. What the heck? There's a 40 here. Okay. So if you see a number in the front, just ignore it. Ignore it temporarily. Okay. So if you see a number in the front, a coefficient, do what I'm going to do. Put a bracket and plus c. Okay. And in this bracket, do the rule, the first rule. So you add 1 to the exponent. If you don't mind, guys, I'm not going to put that step where I do the addition or subtraction stuff. I'm just going to put the final answer, which is x to the 6 over 6, like that. And then it's on you to remember to clean it up a little bit, because that's not looking too pretty. There's various ways you could write it. I would probably just end up writing it like this. But you could write it as, you could put the 3 underneath the x to the 6. I do expect you to reduce it, though. That's not negotiable, okay? Don't forget, you want to clean it up. You need to reduce that fraction. So we can apply this to the next few questions. Oops. So if you don't mind, I'm just going to go a little bit on autopilot here and just type some of these answers, and I'll talk less. So this is 10 x to the 4 over 4 plus c. So that'll become 5 over 2 x to the 4 plus c. I do have some reservation about the next question. I would do the following. I would write it as a fraction. I mean, you don't have to, but okay, you know what? I won't write it as a fraction, but I don't like the decimal in there. So in this case, you'll have x to the, I'll just do it with decimals and show you why I'm not really proud of this answer. I'm not very proud of this answer because there's decimals. It's bad form to leave your answer in a decimal on the denominator. So what you could do here is multiply the top and the bottom by 2. So this thing that I just invented out of thin air, I'm going to give it some color. I'll make it red so that you're like 2 over 2 was not part of the question, but it is part of the answer. So that's going to be 2, and then 12.5 times 2 is 25. I don't want to see decimals on the denominator. I think that's very poor etiquette for fractions. Maybe I'll put this a different color because it's like I'm having a bit of a style thing going on here, a little bit of consistency. Okay. How are you with the pace, people? You guys okay with this pace? Thank you, Amir. Let me know in that chat if you have any questions. Don't forget, as I'm doing the lesson, I'm looking at the chat pretty much every 10 seconds. I don't get 18. Okay, what part of it, Nathan? Where is the issue? Is Is it this thing? Whoops. Tell me specifically. Is this thing okay? Is this thing in black okay? Decimal is okay for the power. It's just the denominator that I'm not happy with. Yeah, you are allowed to put it in fraction form. You could write this as 23 over 2, for sure. The only reason I didn't do that, I was trying to present the cheapest way possible to the answer. The cheapest answer, but yet the most, still good presentation. Nathan, let me know what's going on. You had a question there. So we're just adding 1. Yeah, you are allowed to put it as a fraction, Jai, just if I wasn't clear with my answer there. Okay, so the answer here is this. That's the rule, okay? I'll fix it, don't worry. I think one extra line of writing will fix the issue. You could put a 4 there if you want, but it's better to put a 2 because it's the lowest fraction that you want to use. So this is the antiderivative. This is the answer in terms of just the rule. But the thing is the denominator is a decimal. I don't like the fact the denominator is a decimal. So what I'm going to do is I'm going to double it. I double the denominator, but I can't just do that without doubling the numerator. So that's why I multiply by 2 over 2. It's just to make the denominator a whole number, see, 25. But then there's a 2 on top because I have to double the numerator as well. So I hope that addresses the 2 questions in the chat. That's pretty much it. I think we should move on to question 19. 19. To do 19, we need to keep in mind that the question needs to be written as an exponent. Does anybody remember square root? Square root. What is the exponent? Thank you, Jai. Yeah, that's a half. And if we apply the rule, I'll do this one slowly because it is fractions. So the rule says that you add 1 to the exponent and you divide by the same thing. So this is going to become x to the half plus 1 over half plus 1 plus c. And of course, I expect you to know your fractions. So this is 3 halves, and that's 3 halves. And that answer is all cute, but I don't like a fraction within a fraction. So we'll write this as 2/3 x to the 3 halves plus c. Whoops. There you go. So that's the answer. The answer here, people were saying something about red. Red is the final answer. Red is what I want to see. Now, if you don't want to leave it as a fraction, you could write this answer as a root. But the answer I present here is the least amount of work I want. If you want to go further, you're more than welcome to, but this answer here is perfect for me, okay? For those that prefer, though, you could write it this way as well. You could write it as a root. But I don't want you to write it as a root. Don't waste your time. If I write it as a root, it's just for the purpose of just clarifying your exponent laws, but I don't care which one you write, okay? You could write the first one or the second one. But if you want my advice, make your life easy and just stop where you need to go, which is this. Like, don't go too far. So we're going to play this game a little bit now. The next batch of the next examples like this, and then after that we're going to do some polynomials. So in this case, this one here, it's already in an exponent form, so we're good to go, I think. I feel like copying and pasting that all the time. So that's x to the quarter plus 1 over quarter plus 1 plus c. And then a quarter plus 1 is 5 quarters. What about the 10? Good call. I didn't write the 10 down. I will do that in 1 second. I got ahead of myself there. So see this 10 here? I had tunnel vision there. You see that I had tunnel vision. I was trying to just do antiderivatives without thinking about what I was doing. So thank you, Jai. But is it a catastrophe here? Am I gonna like get ruined on this? No, it's okay. I can always fix it. So there you go. The answer is close. We're almost there, people. It's just this thing here. Make sure that you clean that up there. So 10 times 4 over 5, that's 8. I don't have the answers in front of me, so keep me honest, people. Not bad, not bad. So that's kind of the worst of it so far. We're going to go back and do some polynomial antiderivatives now. So this should be a little bit more manageable. And I'm looking ahead. We're gonna see some tougher ones at the end. So we're gonna do about 7 questions. These next 7 questions should be okay. And then the last batch of questions is kind of the tougher stuff. And then we'll be done the lesson. I don't think we're gonna go to 11 today, but we are gonna be doing a lot of we're gonna be doing a new technique at the end of class here that's gonna be tougher. So dealing with polynomials, I'll just say with more than one term, just do them one at a time. Okay? So if you have more than one term, it's just separate questions. So let's take a look at 21 here and see if we can navigate that. So the first one is 2x. Yes, many of you remember that the answer is x squared, but let's say you don't remember that. You can do the bracket thing and put x squared over 2. And then the antiderivative of 3, remember when you just have a number, it's 3x. And don't forget the c. So this question is really just taking 2 previous questions and kind of gluing them together. If you go back in the notes somewhere, I bet you we have both of those. See? There's the 2x. That was actually example 1. Notice that example 1, we just kind of, like Star Wars, we used the force here, right? We just knew the answer. But then here, we're actually just using the formula, because you can still use the formula. And also, the constant is always the constant times a number. We saw a few of those earlier as well. It was actually this question. See it? It was question 6. So if I go back here, this is really just examples 1 and 6. I'll say that here. Combine. Okay? Now let's keep on going here, and we'll just kind of plow through the next 3 questions. I'll shrink the font a bit, just so that I can get more of them on the box here. So in this case, we'll have 3x squared over 2 minus 5x. Don't forget that c. This answer is actually good. At the end, there's nothing wrong with it, but just for like aesthetic purposes, I want to see those numbers kind of tighter together like that, a little bit more clean. But this answer mathematically is in good form. There's nothing that I could argue is not nice about it. The next one's a triple. So now, like figure skating, you're onto your triple spins. So we'll do here 6x3 over 3 plus 8x2 over 2 plus 3x plus c. And of course, you could clean this up, and I will clean it up in a second. So that's 2x cubed plus 4x squared plus 3x plus c. And example 24, that's a quad. Some more of the same, okay? Don't get intimidated by these. It's the same thing over and over again. It's just more terms. So example 24 is like 4 easy questions kind of put together. So the first one's 3x cubed. So that'd be 3x4 over 4. And then 5x squared. But antiderivative of x squared is x3 over 3. And then 2x is x2 over 2 for the exponent part. And then the antiderivative of 1 is just 1x if you want, plus c. And of course, you can clean this up a little bit if you prefer. These first two terms do not require any simplification. They are correct as they are, but this one here I'm not happy about because you can reduce, and you should reduce. And finally, this one is not necessary, so let's just get rid of it. So we're going to do 3 more questions, and then after that we'll shift to the technique that I need to teach you, which is the hardest of the antiderivatives that you will learn with me. And that is it. Just to keep in mind, everybody, all the techniques for antiderivatives that you need to know for this booklet, I am teaching you all of the techniques today, and then next 3 weeks, I'm going to recycle them. So you're not learning any new techniques in terms of finding an antiderivative. I'm getting it all out of the way today. And then for the remaining 3 weeks, we're going to take this stuff and write it more fancy. And we're going to apply it to practical questions. So, question 25. Let's rewrite this as an exponent. What's x to the cube root here? What is the exponent for x for cube root of x? Thank you, Jai. So this becomes 9. And then you have x to the over. And that exponent is 4/3. And then minus 3 x squared over 2 plus c. Which of course you can clean up a little bit. So 9 times 3/4 x to the 4/3 minus 3 over 2 x squared plus c. And then you can clean this up a little bit here, 27 over 4. And that pretty much irons out that question. Okay, 2 more of these, and then we'll talk about that new method. Okay, example 26. I'm going to write down the function a different way. So that's going to be 8x to the negative 5. minus pi. All right. So all of these things I'm showing you today, be prepared to write a quiz on this next week. So we haven't talked about MyLab since December, but basically MyLab, for those that are not familiar, is the software platform that you need to get to do the quizzes and the tests for this course. And what I usually do is in the third hour of class, I give the class roughly, in the past it was 20 to 30 minutes depending on the level of difficulty. And I just say answer a few questions, or answer depending if they're short answer or not. I haven't decided how long your quizzes are, but most likely I'll be leaning toward half an hour, just depending on the logistics of how much I have to teach in the class. So anyway, we'll do our quiz next week and we'll see how it goes. So in this case, you might get like 3 or 4 questions of varying difficulty based on what you see in class and what's in the homework that's recommended. I should mention, for those of you who are like, what's the homework? In the course outline, sorry, in the workbook, in our booklet, I have the questions that are recommended right here. See? It says here Washington 11th, and I just have section number in there. I don't have any specific questions from the section. I just ask you to do a bunch of questions at your leisure. So try to pick a variety of questions from that section. There's just, MyLab and the textbook have just so many questions that the more you do, the better. And the most successful students found that this is the case. They just did random questions from the book, and they did lots of them. Okay, so in this case, we want to add 1 to the exponent. So that'll be x to the something over something minus pi x plus c. So that exponent, what is the exponent up here, everybody? Can someone tell me there what it is? Someone else? A name that I might not have seen for a little while? What's the exponent there? Thank you, Asim. Yeah, it's -4. Thanks, guys. -4, -4. Okay. So then this here becomes -2 over x to the 4. So 27, much of the same. You just want to take this here and rewrite it as an exponent. So I'm just going to do that right here. Maybe I can just squeeze it here actually this time. So that's equal to x to the half minus x to the -3. So that equals x to the 3/2 minus x to the -3. So you see that? I just rewrote the root as x to the half, and then I added exponents. So if you want here, that's x to the 1. Okay, so it's 1 plus a half. So finding the antiderivative now is much similar to the previous ones. So that's going to be x to the 5/2 over 5/2 minus x to the -2 over -2 plus c. Remember, you're adding 1. -3 plus 1 is -2. So that's 2/5, and then some more information shortly to follow. So that's x to the 5/2. And then over here, we have 2 negatives, make a positive. And the fraction, okay, we have a number here. We have a 2, and then we have x squared. So the x squared's on the bottom, and this 2 here also stays on the bottom. So it's 1 over 2x squared plus c. And that represents kind of the worst of it in terms of the power of a function. Sorry, power rule, I should say. So what about this new thing that I'm talking about? So this is where things get a little bit sketchy. So we're going to be doing a technique now, which is the last thing I'm going to teach you today. And we're going to do it about 5 times. And then that will be the rest of today's class. That's going to be it, okay? So I want to go back here to this thing. Power of a function rule. See this thing over here? Let's take a look at this in a little bit more detail now. I want you to look at the question. See the question here? It's 2x cubed plus 11 to the 4. You see that? You got to the 4. And what about the derivative? When you look at the derivative, so if you take that, let's color this purple or whatever. When you look at the derivative, you see that it says cubed here. See that? And what do you see? You see the same thing, the same bracket with one exponent lower, and then you see some stuff in the front. You see that stuff in the front there? So I want to talk about that because that is going to be of interest for the next questions that we do. I'm just doing something on my desktop, sorry. Okay. So take a look at this question. We have something in brackets to a power, and then we have some stuff in front. So it's very reminiscent of using this rule. Now, for those of you that have studied antiderivatives already, you may be familiar with something here, and I'm going to mention it on the side here. For those who know, so for those of you who know or prefer, you can use something called the substitution method. I'm not going to be using substitution method though here because I did not teach you something else in the fall called chain rule. So for that reason, I'm not going to use this. But I'm going to go over here and talk about the method that I'm going to teach you. And it's very similar to what the book does. And that's really the reason that I do it this way is because the book does it this way as well. So I'm going to go out on a limb here and guess the answer. I'm going to guess that the antiderivative is equal to this. Now you might be like, how did I guess that? How was I able to just make that guess? I'm not saying this answer is right. This is not the right answer. Yes, Ethan, the chain rule, yes. I'm not saying this answer is right. I'm just going to guess it. I want to just see, okay? I'm curious. I'm just curious, okay? Now, if you make a guess, you should check if you're right. So what I'm going to do is, okay? So I'm going to take this guess here, and I'm going to find the derivative of it. If I get back the original function here, if I get back this, that means that my guess is perfect. If I don't, then I'm out of luck. Let's take a look. Let's try it out, okay? I'm going to check it. I'm going to take the derivative of my guess. Using the rule here on the right in red. See this rule here? I'm going to do the rule that I started you off with class with. So that's 3x squared plus 1 squared. And then I take the derivative of the inside of the bracket. Basically, I'm doing this thing over here. And that's 2x. And what do you get? Let me know in the chat. Was my guess good? How would you qualify my guess? Would you say it was a good guess? Was my guess perfect? Amir says it's close. Anybody want to vouch for me and say it's perfect? Yeah, it's perfect. OMG, it's perfect. Isn't that weird? It's okay. Anything less than perfect for me is a failure. Just kidding. Just kidding. Okay. So anyway, that is the answer. This is the answer right here, okay? We got lucky. Hey, we got lucky. I'll take lucky. So that's it. Now, what if it wasn't perfect? Could you fix it? And the answer is yeah, you could fix it. So I'll show you that this approach will work in the situations where you could be off by a number. And I'll just mention that if this method is not possible, if this method does not work for you, sorry, this doesn't give you an answer that works, it means that the level of antiderivative that you're being asked to do is beyond the scope of this course. I should mention to you, there are hundreds of methods for antiderivatives, okay? They just go on and on and on and on and on. And eventually there's antiderivatives that you can't even solve for. There's antiderivatives there's an antiderivative, it's really a formula, that if you can figure out some specific details about the possibility of its having an antiderivative, you will win $1 million. I said that again. If you can identify if there is the quality or the possibility of finding an antiderivative for a specific function, sorry, for a specific equation, you will actually win $1 million. Did you guys know that? Is that scary? Well, obviously, I'm not talking about that. I'm talking about the Navier-Stokes equations. It's a very famous. It's funny that you say that, Asim. My PhD is based on the work on this equations, because my PhD is in aerospace and specifically in fluid mechanics. I don't want to sign up for this newsletter. Leave me alone. uh, there's a very famous movie, not a famous movie. There's a movie about someone that supposedly solved it, but yeah, it's pretty weird. Let's try some more of these questions together, people, so I don't get too much off track here. So we're gonna make a guess. Ethan, there is a method for doing it, but I won't be covering it in class, okay? You can definitely look it up on YouTube or with other places. I'm not doing it because the book doesn't do it that way, and I don't want conflicting ways to teach you when you look at the book to study later as well. So the method you can look up, Ethan, is called the substitution method, okay? Sorry if I spelled that wrong. You're welcome. I'm not trying to dodge the method. It's because I didn't teach you something called the chain rule in the fall just because of time. So it would be unfair for me to show you substitution without teaching you the chain method from the fall. For those that are looking back at this video or any other random people that might come across the video, like we went from nothing. We went from zero to knowing how to do derivatives and antiderivatives in less than 8 weeks if you include the stuff I'm doing now with you. I can't stress that enough. For many of you, that's an incredible leap in terms of your mathematics knowledge. So we're going to guess the answer. So the guess is going to be x squared plus 1 cubed plus c. And now we're going to check it. So I think that this here is going to be the answer right here, okay? This is definitely a video when I record this eventually, and sorry, when I put it online. These examples, I encourage you again to look at these a couple times over. So make sure you go through and watch these again because they will be recorded for you. So we're going to guess the antiderivative to be one power higher. And now we're going to check by finding the derivative of the antiderivative. So the derivative of this, according to the power of a function rule, according to this rule here, that would be equal to 3 x squared plus 1 squared times 2x plus c. Sorry, just 2x, sorry. And let's take let's clean up that derivative a little bit. So that's going to become 6x times something. Okay, so here's the big moment. Here's the big moment. Is this answer correct? Is this antiderivative correct? And the answer is no. This answer is wrong, okay? My guess here, sadly, was not correct. Because this thing here should be the same as that up there. So those things have to be the same. Are they the same? Let me know in the chat. Are those two the same? Well, obviously not. But what could I do here? Could I put a number here that could save it? What number would I put in front of this bracket so that I could save this question? Ah, Ethan. Ethan and Jai, yes, it involves the number 6. And Ethan, you are correct, sir. If you put 1/6, no, Jai, that's good work. If you put 1/6 there, what happens? Well, what happens is, let me put that 1/6 there in blue. Let me put it in blue because I'm just adjusting my guess. It's like, you know, when you have a birthday and you're like, are you 1, are you 2? You just keep on guessing, right, until you get there. If I put a 1/6 there, that 6 and the 1/6 cancel. Don't see how they cross each other out? Boom. Now are they the same? Now are they the same? Is this the same as this now? Yep. So there you go. That's the method, people, okay? You guess, you check, and then you do a little adjustment at the end if necessary. Pretty much, Ethan. And I assure you that if you do explore the substitution method, you will definitely be able to handle more questions. But in terms of the scope of this course, what you did right now, it's a solid method of guessing. Basically, that's what this is. It's a very intelligent way of guessing. That's all. This is the way the book does it. This is the way that I'm going to do it because the book does it that way, and I don't want to digress from what the book does, because for those that will be using the MyLab and the textbook to practice a lot, I want to do it that way so that you're not confused. So this is really about being educated guessing. Educated guessing. Okay, here we go. Let's try another one. So we're gonna do 3 more of these guys, and then we're done for today. Okay. So forget about, let's not take a break. Let's just do these 3 questions, and then we'll call it a day. And that's pretty much it. So okay, so let's take this question here. I'm gonna rewrite the question. Okay, so there's the actual derivative. Now we want to guess the antiderivative. So I'm going to guess the antiderivative. And I'm going to just say it's this. I'm going to say it's the thing in the bracket. And I'm going to add 1. I'm just going to add 1 to it because I feel like it. Well, because that's what the pattern is. So there, that's my guess. This is what I think the answer should be. This is exactly what I think the answer should be. But now we're going to check. Let's check and see if this answer is correct. So I'm going to take the derivative of that and get -2, 1 minus x squared to the -3. And then the derivative inside the brackets is going to be negative 2x. I don't know why it's changing color back to green. This is very annoying. There we go. So this becomes 4x, 1 minus x squared to the negative 3. Okay. Comment on this answer. Would you say that our guess is perfect? Is this the antiderivative? Yes, it is. It's perfect. Yeah, because you see this and this are the same. The derivative of the antiderivative is the same. Let me write that down here so that you can read it later. Just a comment here. Make sure that you write your answer with positive exponents. So one last thing here to do is to write the final answer. So the answer to the question down here is in blue. It's going to be 1 over that. So this is the answer to the question. That's the answer to the question, okay? You're always expected to write your answer with positive exponents. That does not change moving into this course. So that leaves us with 2 examples. Maybe we should take a break. Who would like to have a break? We're going to do 2 more, but maybe it's better if we just take a break. Maybe it's just better we take a break. 4x. Yeah, it's 4x. Yeah. You mean over here, Jai? The blue. No, the answer in the blue is this. It's just this thing here. This is the answer. I just don't like the fact that it's negative. You see this negative 2 here? Yeah. The answer to the question is the guess. You're guessing the answer. See, guess the answer. Thank you for asking that, Jai. You're guessing the answer. Okay, yeah, let's take a break, everybody. I realize that's 9:55. Guys, take a break till 10:10, and then we'll come back and just do those 2 questions. It's probably better that you guys take a mental break as well. So be back here in 15 minutes, okay? Class will resume at 10:15. If anybody here feels like going, you're more than welcome to go, but we will cover examples 31 and 32 after the break. Besides, I need to go get some coffee. All right, see you in a little bit. So now that we've rewritten the function this way, we can just add 1 to the exponent for our guess. So we're going to guess the answer. So here's our guess. So we're going to take the quantity in the brackets here, this thing here, and we're going to add 1 to the exponent. Like that. Plus c. And we're going to check if our guess is good by finding the derivative. And for that, we use the power of a function rule. So bring that negative 3 down. 9 minus x cubed to the negative 4. And don't forget to take the derivative of this. So that's going to be negative 3x squared. We can simplify that a little bit further by taking this term here and multiplying by negative 3. So we're going to get 9x squared. And I'm going to pause right there. Okay? This is the answer that we want. That's supposed to be the answer to the question. Let's comment about that answer. Well, hopefully, the derivative of our antiderivative gets us back to where we started. See? In other words, are those the same? Comment in the chat. Obviously, are they the same? Are they close? Is it fixable? Okay, they're not the same. I agree with you 100%, Jai. They're not the same. But can we salvage this? It's fixable. Yeah, so how do we fix it? What should I put here? What should I put in front of this bracket preemptively so that it makes it better? That is correct, Jai. And I'll explain that for the class so they understand. Let me say it as simple as possible. We got a 9 here. You see the 9 here? But we want the 11. We want to have an 11, not a 9. So the cheapest way to do that is to preemptively put 11 over 9. If you put 11 over 9 there, that will carry over through the whole question. See, 11 over 9. And then if you clean this up, after you clean up all this stuff here, these numbers, all of these numbers here, you're going to get 11 over 9 times 9. So then the 9's cancel, and you're just left with 11. And that is perfect. Look at that. They match now. They're the same. So now this is the answer. Okay, that's it. One thing I'm not going to discuss too much here, but it's positive exponents. So you should always present your answer with positive exponents. So let's do that now. So this is your final answer, but with positive exponents. And then we'll move on to that last question. So this is an easy fix. Just take this thing here and bring it downstairs with the positive exponent. That's the answer to the question. I haven't been checking my answers against the solutions, but I'll just double check that one because it is a harder one. Okay, so that's good. Now, if you're wondering, no, don't worry about the check. You don't have to, these ones here, the question from Jai is that, should I make these positives? No, don't bother. This stuff here, all of this stuff here, you don't have to do anything fancy. Yeah, because you're only guessing the answer, and this is the only thing I care about is the answer. The answer is the blue thing should have positive exponents. The exponent here should be a 3. Ethan, it should be a 3. I'm just taking this thing here, which is our answer, and I'm writing it better. See, I'm writing it better. Okay. Now, what's going to happen is you guys are going to go to Blackboard, and I will post the solutions. It's okay. I'm going to post these solutions at the end of class, okay? But let me show you. I'm just going to take a screenshot of what the solution looks like to this question. It's just, I'm just doing the screenshot right now. There's a bit of a lag time on my computer. This is what you're going to get on Blackboard. You see how I've typed it all out? Make the guess, check, do some stuff, final answer, okay? So everything that I've said to you in the lesson today, I promise you that if you missed anything, the solutions are going to be crystal clear, okay? They're going to give you the full explanation with sentences. So let's do this last question, and then we'll move on. So let's take the question here and rewrite it as an exponent. So this is going to be equal 5x cubed, x to the 4 plus 1 to the half. And at this point, it's a matter of making a guess based on this. So let's guess the antiderivative. So we're going to do x to the 4 plus 1 to the 3/2. Where did I get 3/2 from? I added 1. So I took 1/2 plus 1. I took 1/2 and I added 1 and I got 3/2. So remember, this thing here that I'm highlighting in blue is the answer. But let's see if that answer is the proposed answer. Let's see if that answer is indeed the correct antiderivative, or do we need to do some adjusting? So we're going to clean this up a little bit by bringing the 4x cubed over here and getting 6x cubed when you multiply all together the coefficient in there as well. So you get 6x cubed, and let's discuss. So, is this thing here the same as this thing here? Are they the same? Yes or no? No. Okay. Are they close? Are they close? What's the issue? We have a 5 here, and we have a 6 here. Very good, Jai. So what you want to do is you want to turn this 6 into a 5. And that just requires you putting over here a 5 out of 6. Because then that 5 out of 6, it just carries through the answer. And you end up with what you need. Like that. And now we're good. So the answer to this question is this thing right here. Remember, the answer is the guess that you're making. All right. That does it for today's class. I'm not going to teach for that long in the future weeks. Maybe with the exception as we get closer to the test, I might do a little bit more instruction per 3 hours. But anyway, I think that's enough for today. We're going to repeat very similar skills next week. We're going to review this stuff again. And as far as you're concerned, this is the hardest. These last few examples are the hardest thing you're going to see in this chapter, okay? In terms of like technical skill for finding antiderivatives. Everything else that we do beyond this is based on application and using more formal, more fancy notation. So, welcome back. Welcome back to part 2 of our time together. And I look forward to having an awesome 15 weeks. Okay? I hope you have a lovely semester, and I hope that your holiday was good too. I'll be here for questions, but for now, the lesson is complete. Thank you.